Hello. So we're given this particular problem of a projectile motion of an object that's being launched from a edge of the cliff, and this time, the the object is being launched at an unknown angle, and so the question here is, like at what angle should the object be thrown in order for the object to reach the horizontal displacement distance as shown, and what time does this occur? So when we're trying to solve this, there's a bit of a trigonometry identity that's involved. So that's what's could be somewhat bit confusing, but we'll go through it. Okay, so as just as we tackle any projectile motion problem, there's the vertical component and horizontal component. So vertical component usually takes into gravity into consideration. So there's acceleration, and then there's the initial vertical component velocity, and of course the height of the cliff, or height of the tower, like wherever that is, and then of course there's time involved. And now in the horizontal component, it's a little more simpler. It's more straightforward. There is the horizontal component velocity you have to take into consideration, and and then just time. It's a multiply that together, it gives you distance, the horizontal distance. And what do we know so far? We know that that we're given the horizontal displacement distance at 110 meters, and we know that the initial overall velocity is 55 meters per second. And so if we plug that in, the only unknowns in this case would be the angle and the time. So now you have to kind of manipulate it around in such a way that you are isolating time value. So you have it works out as being 2 over cos theta. Okay, so now in here, like, you have to consider the trigonometry identity, and there's gonna be identity involved with something that ties in the secant with tangent. So as you can see, secant is 1 over cos, and tangent is sine over cos, and secant square equals to 1 plus 10 squared. So that's the identity that's mainly you have to understand, you have to look out for as you're doing this particular problem. Right, so we have now the vertical component, and we have to somewhat plug in the value that we got. So time value equals to 2 over cos theta. Now we have to plug that value, we have to plug that into those variables into the vertical component. So once we do that, we get these vertical component equation, and if you look to the final, the equation will be 0 equals to negative 19.6 multiplied by 10 square plus 110 10 theta plus 25.4. Really it's about plugging it in and then making the other side 0. So that's ultimately what needs to happen. Okay, so now we've seen that there's 10 theta squared plot, and then there is also tan theta. So this is very much like a quadratic equation. So you have to use the quadratic formula to find the tan theta values. I mean, there's obviously two values, but one of the value turned out being negative. So so that's why since only the positive value is valid, since only positive value is the one that should be considered, we go and look at the positive value. So positive value turned out being 5.834, and then you inverse it to find the theta, the value of the angle, basically. So it turns out being 80.27 degrees. That's the angle. And then the other question we're trying to solve is, at what time does this occur? So the time, in order to find time, we just have to, if you look at it, the time equals to 2 over cos theta, and we know what the theta is. We just have to plug it in now, and it turns out as being when we plug in 2 all over cos 80.27 degrees, and it gives you 11 seconds and 83 seconds. Yeah, so 11.83 seconds for the object to travel horizontally 110 meters. So that's how you would solve this particular problem. The only part that could be confusing is just the trigonometry identity, but other than that, everything else is very, I would say, mechanical. It's very just plug it in and put those values in, and that's pretty much how it is. So yep, and thanks for tuning in to get to listen to my informative tutoring. So yeah.